I want to clarify a comment I made on slide 40 of lecture 1, just to put it in the right context. The slide was put there basically to illustrate the difference between a coherent twin and an incoherent twin, and it also had some information about the symmetry of the twin compared to the parent matrix. And the information it was talking about was a rotation axis. So basically, when you're looking at the twinning plane, which is the 1-1-1 plane, which is this plane, basically the twin and the parent material share a common rotation axis, which is perpendicular to the twin plane, and it's basically a six-fold symmetry, or if you like, and that is, if you're just talking about rotation and the arrangement of the atoms on that plane, that 60 degrees refers to that symmetry rotation axis. And what I was confusing it with was the relative orientation of the close-packed planes in both cases, the 1-1-1 planes. So let me just illustrate what I was meaning by that. So the base of my model here is the 1-1-1 plane, and there is another 1-1-1 plane. So these two 1-1-1 planes, we're kind of looking, trying to get them lined up. So we're looking in a direction which is in both planes. So we're looking at a direction which is common to both planes. And the angle difference between these planes is just over 70 degrees, 70.5 degrees roughly. What I was confusing it confusing that 60 degrees with, which is not the same. 60 degrees refers to that symmetry. But what it does, what I can show you is typical angles to consider when you're looking at the twinning operation. So let me look at a FCC crystal here. I'm going to twin this top half of the crystal. We're looking perpendicular to the twinning direction, so 1-1 bar 2 direction, and we're looking in the 1 bar 1-0. We're looking at that in the 1 bar 1-0 direction, and we're perpendicular to the 1-1 bar 2 twinning direction, and also the twin plane, which is this top one. So let me twin the crystal now, like that, and you'll see the orientation of the 1-1-0 close-packed direction between the 1-1-0 direction between the atoms in the close-packed structure, which lie in the 1-1-1 plane. So our 1-1-0 direction here is the closest packed direction in the structure, and when we do the twin, we apply a twinning operation and move by one partial over in the shear direction. You'll see how this, if you like, common direction, or the close packed direction, shifts from there, sorry, to here. So I'll put it back where we started. So this change in the orientation between that direction and this direction is about 39 degrees.